where we're all from and why we're interested in being here. And so I won't recap kind of any of the specifics around the logistics of how this all works. You have the Slack channel and you have the Notion page, and we've put all of the resources necessary for this course on there. So what we'll be discussing today is just a little bit of a recap about the problem at hand. I'm going to be talking a little bit more about drones and drone data collection, and I'll also be showing you actual examples of data that you will be using. And then next week, we'll really get going into what it means to train an ML model in the context of this drone imagery. So again, please, if you haven't already, make sure that you're linked onto the Slack channel and that you have access to the Notion page. So without further ado, what are RPAS or drones? So the earliest iterations of drones were actually pigeon cameras, and these were invented by a pharmacist, I think in Germany or in Austria. He strapped cameras to pigeons in the early 1900s, and these were to deliver prescriptions to his customers, and the cameras were for tracking these pigeons. So in case a prescription got lost, he'd be able to figure out exactly where those pigeons went. These days, drones are also known as unmanned aerial vehicles. And another kind of more official term, it's the Transport Canada definition, is remotely piloted aircraft system. And just for your entertainment and my amusement, here's a picture of a pigeon camera, the earliest iteration of drones. And here's a picture that the pigeon actually took, an aerial view over Frankfurt, Germany. One can imagine how different these images were kind of at the turn of the 20th century. So there are different types of RPAS, and I've put a few of the more common ones on the right here. So there are multi-rotor drones, and these are typically used for kind of aerial photography and surveying. They often can't fly as far, and they're a little bit less nimble than, for example, fixed-wing drones, which look a bit more like a plane. And these are used more typically in forestry and agriculture for more kind of remote and larger areas. We're going to be working with data collected from multi-rotor drones, so the ones on the top left, and I'll go into detail about exactly which ones these actually are. So let's talk a little bit about drones in the context of forestry and conservation. You're all here because, you know, we've established this problem about counting and classifying trees using drones, but I want to step back a bit and just talk a little bit about what it might mean to use drones in the forestry context. So a few years ago, or maybe a couple of years ago now, I did a quick little literature review looking at different types of technologies in forest ecosystems for, you know, counting and monitoring and measuring and understanding them. And it turns out that unmanned aerial vehicles are actually gaining a fair amount of traction pretty recently. So it's only really starting in like 2014 or 2015 that these are being used, at least in research contexts, in forest environments. So it's still quite a new field, and there hasn't been a lot of work done in this space. And that's potentially really exciting for us because we have a lot of data and you're interested in using it. So I think that's pretty cool. And it's really worth mentioning that this is kind of like the forefront of certain types of research in forestry and conservation right now. And so a lot of what's being used with drones in forestry is to get at like structure, so like 2D and 3D metrics, like what's really going on in the forest. Sometimes we call that an inventory. So what kind of forest resource do we have? And then how can we monitor that in kind of a more efficient and in a higher resolution way, in a way that allows us to make like data-driven and informed decisions. So drones have been used to, you know, inventory a forest, so get at like exactly what that forest comprises of from a species perspective, from a size perspective, et cetera. It's also been used actually for forest fire detection, which is really interesting. So looking at either like fuel loads or smoke, depending on what you're looking for in the forest fire context. It's also been used for conservation purposes, so tracking wildlife and animals through forests. And in the urban context, people are slowly catching on to the fact that this can be really useful. Drones have been used to monitor invasive pests and diseases in urban forests. It's also been used to measure certain metrics or features at, you know, the tree or site level. And what's exciting about drones is that, you know, it provides this additional level of detail that's often been really difficult to get at in urban environments. Often we've had to rely on satellite imagery or ortho photos, and those aren't always at the resolution that drones provide, because drones fly a lot lower and their cameras are often very, very good. So these are just a couple of examples of how drones have been used in urban contexts and urban forestry thus far. So using machine learning to map urban trees and classify species, that's kind of what we're going to be hoping to do now. So that's pretty exciting. And that's really recent. That was only published last year. And then comparing drones or drone data with more traditional techniques that have been used in urban forestry and figuring out, accuracy and precision and how drones can add to that, level of data to allow people working in urban forests to better make decisions. So again, these are only a couple of examples, but there really aren't that many out there right now. So we're kind of really working with a novel space. And I hope that you find that as exciting as I do. So let's get down into exactly what our kind of research entails and what kind of data we're providing that you'll be working with. So these are the two drones that we've used thus far. As you can see, they're both multi-rotor. The one on the left, the little gray one, is the Mavic 2 Pro. It's a consumer drone. You can buy it pretty much anywhere, like Best Buy or any kind of like electronics store. It has a RGB, so red, green, blue, just a visual camera like you would have on your iPhone or Android or whatever. And it's very flexible. The arms fold in and out. It's very easy to carry into the field, and it has a great battery life. So, and anyone can go out and buy this. You do need a license to fly it though. And then the one on the right, which is the white drone that you see, is a multispectral drone. It has more what we call bands on the camera, which means that it doesn't just have red, green, and blue bands like you would see on a normal camera, but it has additional wavelengths that it can measure on the red spectrum. So there's red edge and near infrared. You don't have to worry too much about that. We won't even be working with that kind of data. It's really just for your interest, but it just goes to show the different kinds of equipment and payload that you can put on drones to measure different elements of the urban environment. And what's cool about the multispectral drone is that it gets a different spectra or wavelengths, or however you want to conceptualize that, of the urban environment that the eye can't necessarily see. So it can actually get at elements of, let's say, tree health and vegetation health that we would have a harder time seeing with our own naked eyes. We're going to be working with data from the drone on the left, which is just a classic camera, normal kind of data that you could imagine kind of like working with day to day. And these are the types of pictures that it can take. And I just want to show you a few examples of the kinds of pictures that we can take given different angles and different altitudes. So these are taken at the same altitude, but you can see that it's taken at a different angle, right? So the picture on the left, you can easily see the horizon. The camera is about a 45-degree angle from the top. This is kind of a classic landscape picture, right? The one on the right, the camera is angled down a little bit at 70 degrees, and you can see that the perspective is really different. You can get a little bit more of a handle on the trees, and there's a green space over there, and it's just a different perspective, but it just shows how just that little angle change can really provide different information in the pictures that you take. So here's another example. These are taken at the same angle, so 90 degrees with the camera pointed completely down, but at different altitudes. The one on the left is taken at an altitude of 115 meters, so quite high up. That's actually the legal limit where a drone can fly. And the one on the right is taken at 85 meters, so quite a bit lower. And you can see that there's a bit of a difference, right, in terms of what you can see in the images. The trees on the left are they look a little smaller, they look a little bit less detailed. The roads, the paths, etc. It's all a bit further away. The one on the right, you could almost practically see kind of each individual leaf. It's a little bit higher resolution. There's a lot more detail, and that's just from shifting the drone down about 30 meters. So again, just to emphasize that the kind of data you collect, what matters can be the method in which you collect it. You don't kind of fly drones at a single altitude all the time. It really depends on what you're interested in looking at. And here's another quick example. So this altitude change is only about 15 meters, so you can really barely see a difference, but you still see it, right? The picture on the left, you can see the whole tennis court at 100 meters, and you can see kind of that line of trees there. And then the picture on the right, literally, exact same path the drone took, just a different altitude. You can't quite see the whole tennis court. You can see people a little bit more clearly. Maybe the leaves on the trees are a little bit more clear. Again, just to emphasize the fact that there are different ways of kind of collecting data. And you kind of want to be conscientious of what you want to collect, what you're interested in collecting, and then adjusting your parameters accordingly. And so this is the data that you will be working with. So we flew the drone at, usually it was about 85 to 100 meters. And we made the overlap between the pictures quite high. And you can even see it on the left here on that picture. You can see the little camera icons. Those are showing each picture that was taken along that grid line of that park. And you can see that some of them overlap, right? And the more overlap there is, the more that there are going to be tie points between the pictures, which just essentially means that the better the tied together image will be. And the angle that the camera was at was basically just directly looking down because we're interested in looking at the trees. And so we wanted to get as clear a view as possible. And that angle is one of the best ways to do so. So again, this is just highlighting how we collected this data, just to give you a bit of context as to what you're really working with here. And then finally, as I mentioned in the last session, but I'll mention it again, you can process these images to turn these into information that might be useful. So on the very left, we have what's called an orthomosaic, which is basically a whole bunch of photographs and images stitched together to give you a really, really big one. And then in the middle, we have what's called the digital surface model. And that's essentially a vertical representation as well of the points in space. So it gives you an idea of height of all the trees and structures in this image. And then from there, you can derive a 3D representation of the image, which is what's found on the right. You don't have to worry too much about images 2 and 3. So the ones in the middle or on the right, we won't be working with those. We'll mainly be working with those that are 2D, so the one on the left. So what exactly are we here to do? What exactly do we want you to try and do to try and model? Well, the key problem that we want you to solve is by giving you an image such as this one, a drone image, can you figure out, using machine learning, how many trees there are and what types of trees there are? So let's just start quickly with how many trees there are. What is a tree, really? And that might seem like an obvious question, but essentially what you're looking for is you're looking for some type of vegetation that clearly has some level of vertical structure in the environment. So really easily, what you can see in this picture right now is basically anything that looks vaguely green and that looks like it's coming up off the air is probably a tree. So just to zoom in here, I've just highlighted a couple of examples. These are all trees. And if you have any kind of key questions on that, I'm happy to answer that, but I don't want to get too much into it, to get into like what's a shrub, what's a bush, what's a tree. Essentially, it's really anything that's green, clearly alive, and that's coming up off the ground. The more difficult question that we want you to try and answer is, what types of trees are there in a particular image? And in this case, we're asking you to delineate 2 main types: deciduous and conifers. So let's talk about deciduous trees first. What are deciduous trees? Essentially, these are the trees that I think, generally speaking, people find to be the prettiest ones. They tend to have, bigger leaves that fall in the winter. If you live in a climate where leaves fall and then grow back again in the spring, they tend to turn lovely colors in the autumn if you live in a climate where trees turn different colors. And in the winter, they tend not to have leaves. They tend to be bare and they go into a kind of dormant period. And so examples of deciduous trees include oak trees, maple trees, poplar trees, birch trees, really anything that has a leaf that you could maybe vaguely hold in the palm of your hand. And so these trees, these are what they look like. You might be very familiar with them from the ground, but of course, from the air, they look a little bit different. This is generally what they look like from drone images. So the crowns, we call them, tend to be fairly round. Some of these images we're taking closer to the fall, so some have different colors. Some are yellow, some are orange, some are purple, etc. Some are even turning different colors in these images. And in some of them, you can even really see the individual leaves. So if you're kind of familiar with some types of trees, maybe like a maple tree or an oak tree, you can sometimes see the shape, and you can see that they have these distinct leaves, these distinct features from the pictures. Here is another example of what deciduous trees from the air look like. And you can see on that bottom row there are lots of different colors, right? You have yellows, you have light greens, you have dark purples, you have reds. When you see these kind of very brilliant, obvious colors, that is definitely a deciduous tree, because you know that it's turning. It has leaves and it's turning its colors before the leaves fall in the autumn. So those are deciduous trees. Now let's talk about conifers or coniferous trees. Now these don't tend to have leaves. They tend to have what we call needles and cones. And so you can see on the top left image there, we have a nice spruce with some nice green-blue needles and with cones hanging down there on the branches. A classic example of a conifer is a Christmas tree, in case you celebrate Christmas or you happen to like, going to Christmas markets. If you've been to Europe and you've seen the amazing Christmas markets they have there, and they always have those fantastic, huge trees in the squares. Those are balsams, classic Christmas conifers. Or you may be familiar with pines, so pine trees. So there's one on the bottom left there, these long, slender needles. Those are classic pine trees. And if you've ever lived in Ontario, you will know that white pine is a very famous tree there. And then we also have a picture actually of UBC campus on the bottom right there. And I think those are probably Douglas firs. So the big difference between deciduous trees and coniferous trees is that conifers do not lose their needles in the winter. They stay on, which means that they're green all year round. And so this would probably be a very easy problem in the winter, because if you fly your drone in the winter and if a tree is green, there's a good chance that it's a conifer because all the needles are still on it. So what do conifers look like from the drone, from an aerial image? They're also kind of round, but they tend to have this very clear pointy bit in the middle, what we call an apex, but then the needles kind of branch out often. You can see that there's that pattern, almost like a star shape happening, right? From the middle going all the way out. And that's just the way that they're shaped. And because they're kind of these fine needles, you can really see that more clearly than on the deciduous trees. And you can also see in some of these that some of the needles have started to come out of the top. You can see that in one of the middle pictures there. That's just a classic sign that that is a conifer. Here are some other pictures here, and notice that they're all in shades of green, right? Because they don't turn different colors in the fall and they don't lose their needles in the fall. So if you're looking at a yellow or a red tree, that is not going to be a conifer. They all tend to be really various shades of green and even blue, depending on some of the species that you have in urban environments. So I know that this is a lot of information to give you right now, and I know that you're not tree experts, and that's why I'm here to help support this work. But I wanted to give you a good understanding of these two main categories that I want you to work with. And here I'm just showing you other examples of deciduous on the left trees and conifers on the right. And what I'd like you to do for the next 10 minutes is I'd like you to go out into breakout rooms, and I'm going to be putting you into breakout rooms. And I'd like you to just look at these two big images in your group. And I'd like you to write out a clear list of maybe 4 or 5 features that distinguish these two groups. So what are clearly features or characteristics of deciduous trees on the left that you can see, and what are clear features of conifer trees on the right that you can see, just using your naked eye and just kind of using, your own kind of logic and what you can really see in these images, because that's inevitably what you're going to have to do. You're going to have to distinguish these trees when you train your data. And I'd like to give you the opportunity to practice now in a group. what distinguishes these key categories? And I'd like you to come up with a list. So is everyone clear on that before I put you into breakout groups and you can work on it? And what I'll do is I will copy paste this image to the Zoom chat before I kind of let you go
So
here.
I have a quick question, if that's okay.
Yeah, absolutely.
Yeah, you mentioned we won't be using the heat map images with the heights. Why is that?
No, you're not going to be. Sorry, is that what you said?
Yeah, I'm asking why.
Okay. Well, it's because it adds just a bit of complication to all of this. So generally what the height map gives you is that it's just like kind of a vertical piece of information about the tree. But if you already are like identifying it as a tree just using the 2D imagery, for the purposes of identifying and classifying trees, height is just like not that useful. It's useful for other stuff, but just not for like what we're working on right now. And we wanted to keep this like relatively simple, especially since this is like going to be fairly new information for a lot of you.
Okay, all right.
Does that make sense?
Yeah, I guess, but it just seems to me that since conifers have that very conical shape, as opposed to which was the other one? I forget.
Deciduous.
Deciduous, that's the one.
Yeah.
There might be some alpha in the art. There might be some signal in the height maps.
That's an excellent point, and I'm glad that you brought it up, and you're entirely correct. And what we can do is, depending on how this all goes over the next few weeks, if we see that, you know, everyone is super comfortable with like the labeling process and the training process, we could add that in as an additional variable. It just involves a little bit more data, like storage and like sending on our end, which we kind of wanted to avoid because there's a lot of data that we're dealing with right now. But it's totally true. You're right. It does add a nice little complementary bit of information, although this problem is also very solvable just using the images.
Gotcha. Thank you. And one last question, not to take up too much of your time.
No, for sure. Go ahead.
It seems like a binary classification problem. So can all trees be categorized into either conifers or deciduous? Is there no other category?
So that's also a good question. It depends, honestly. It depends on where you're located in the world. So for example, here in Vancouver, we have a group of trees called broadleaf evergreen. And these are, to complicate things, trees that have leaves, like the deciduous ones, but they don't actually fall in the winter. They're like hollies or something else, rhododendron. But I didn't want to add them in here because honestly, even I have a hard time classifying them from the air. And they also don't really tend to be trees. They tend to be more like shrubs or bushes. And so I didn't really want to overly complicate things by adding that in there. But for the sake of your knowledge, 100%, there are trees actually that, let's say, have like really big leaves and don't fall in the winter. And we classify those as broadleaf evergreens. But that being said, at least in most climates in Canada, they don't really grow very well as trees. So you really do tend to have conifer versus deciduous. And in the tropics too, of course, sometimes there are no winters. And so you're going to have, you know, what might be a deciduous tree that loses its leaves in Canada that doesn't do that in like Florida. That's why it's a little bit context dependent, which adds a bit of complication to all of this. But for our purposes, we're like working in this particular climate. And so you can categorize them in these two binaries.
Got it. Got it. That's very helpful. Thank you. Also, I lied earlier. I have one more question. Okay.
Sure.
If we pose this as a supervised classification problem, that typically is a ground truth set. So is there a ground truth data set available? How do I know how correct and incorrect my predictions are?
There is a ground truth set available, and I'm going to be talking to Brahim about how exactly we want to be using that, whether we want to like have it available to everyone yet or not yet. I think Brahim, we should talk offline about that. So yes, don't worry. We will be able to tell you.
All right. Thank you. That was the last
one.
No
problem.
Okay, so are we gonna go into break rooms?
Yeah, I think we can do that. And I've put the link of the presentation, at least of these images, on the Zoom chat right now. But what I'd really like you to do is I'd like you to go to the very last slide, and that's the one I want you to use to come up with a list of features that distinguishes the deciduous on the left from the conifers on the right.
Okay, so I'm gonna stop recording so people can go into the different rooms.